the equation. This is not CNC information to make a 3D printed gun. This is verbal and textual information on one of those processes, one of many. It's also used to make tooling equipment to make conventional weapons in factories. And this is based on an instruction manual that I've reconstructed and modernized compared to one from 1800s or 1907, depending on the year you look at it. Can't tell when these instructions came out. We're going to start with the idea of making what's called an integral chamber barrel thing. The barrel for a shotgun and many other firearms, especially single shot and very simplified versions, has an integral chamber. Some guns have a chamber that's separate from the barrel, like on a revolver. They have 6 chambers, or whatever the number is for the individual places the cartridges go. That's what the cartridge goes in. It goes in the chamber, and it changes the chamber, but the barrel stays the same. This also means that you can take a revolver, pull out that group of chambers, and maybe put in a cartridge with completely different mechanical characteristics and have it fire a bullet either just flying down through the barrel or actually matching with it. There are many cartridges that really do have exactly the same bullet diameter, but the cartridges are very, very different mechanically. Some of them are really big and then neck down. There's even types that do the opposite. And literally they're a big bullet with a small casing behind it. But for the most part, if you're dealing with a barrel on a single shot weapon, like a shotgun or a rifle, it has an integral chamber. The barrel inner diameter is called its bore or its caliber. And they can be translated back and forth. A 12-gauge shotgun has a very loose standard for this, like all the other shotguns, because they're not firing a single projectile that has any close tolerance requirements. They're firing normally lots and lots of projectiles that are thrown out of it, in some cases by having a backing of cork that has to jam fit into the barrel, or it might be a plastic plug or cork. It might be a plastic gas seal, or it might be relying on just it having enough force behind it to throw it past with all of the propellant. I mean, it could be anything. Sometimes it's a bag of the propelled objects, or it could be one large slug, aka just basically a bullet. But in any case, shotguns are not held to a tight standard because it's detrimental to do so. Creating such a tight standard would mean that everything would be to that standard, and then, well, that's not really necessarily a bad idea, but it does limit your ability to do something simple. Choke. If you make a shotgun have whatever the standard is for the bore diameter that year, and make it to where you can put in something that adjusts the bore diameter very suddenly from the last 4 or 5 inches, or maybe the last 2, you can do things like cause the shot to have a very narrow spread early on, or cause it to have a very narrow spread and then suddenly spray way out, depending on what you want to do. You can also do things like add in rifling. You can screw in something that causes the slug, or even the shot for some reason, to rotate. The shot would spread more, while the bullet or slug would fly much more predictably. Some barrels are fully rifled, so they're just a very large bore rifle. So what is the bore of a 12-gauge shotgun? This is based on taking 1/12 of a pound, that's what 12-gauge means, of lead, hard cast lead is specified, forming it into a sphere and then testing the diameter. As you might imagine, this might give you different results depending on the quality of metal, and that's one of many hundreds of reasons that this standard is a loose one. And the bore diameter for that is 0.725 inches, or 18.42 millimeters. Now, obviously, if it's not being held to high tolerance, you could just say 18.4 millimeters, or 0.72 inches, or 0.73 inches, or 0.725, which is what it's supposed to be. Or just call it 72.5 caliber, which is what that means. Now, that means that for the majority of the inner diameter of the barrel and or its written stated value. If you're a Canadian, you already know about this recently. A decision was made that if something's over a certain number of millimeters diameter in the barrel, it would be legally classified as a weapon that must be registered a specific way. And suddenly everyone said, oh, shotguns are illegal or something. No. It was based on whatever is the bore diameter of the majority of the barrel if it's consistent, or whatever is stamped on the side. You can take a 12 gauge shotgun and underbore it by putting a sleeve in it and make it fire 41 caliber objects. It doesn't have to do anything else. It's based on what it was stated as. You can get barrels that are overbore. Instead of it being .725, there are shotguns that are .81 inches, 81 caliber, because they're rifles, but they're treated, because they use the 12 gauge shotgun shell as the base cartridge, it's a brass cartridge, to stick a slug in it, and it's an elephant gun, a fully rifled freaking stopping rifle. It's an 81 caliber freaking, well, elephant gun. And it's a destructive device and should be regulated that way. But the majority of people who own them have no reason to use them that way, and they just treat them as a shotgun. A lot of them don't even have rifling anymore, so they work fine. They just don't fire particularly efficiently, but that's not really important if you're just trying to shoot something 20 feet away or just shooting targets. And the Canadian government, like the American government, has decided not to really regulate these things because it's dumb. But the Canadian rule is that any gun that exists that's over a certain diameter, they're allowed to, on their discretion, demand that it be treated as something else. If it's really a rifled barrel, and you do have elephant gun bullets, cartridges, to shoot a real bullet at 81 caliber, maybe they could regulate that. But what is that diameter? At 81 caliber, it's 20 and a half millimeters approximately. It's a little over 20 and a half millimeters. So if it's under that, it's under 80 caliber. You're getting to the point you're down near the 20 something. But a bunch of people there politically and ideologically decided to say, but there's a forcing cone. What's a forcing cone? Well, we're going to do that in this video. To make a barrel like that, there's several methods. I'm going to tell you about the evolution of it. One of them is the cheap shotgun barrel blank formula. You find out what the base of the biggest, fattest cartridge you're going to find on the market for a 12 gauge. 12 gauge shells have different diameters. You see, the only thing that's standardized is 12 gauge equals 72.5 caliber, or 0.725 inches, or 18.42 millimeters. That's the only thing that's standard for 12 gauge. Okay, let's say we did that with the entire hunk of pipe. Okay, the cartridge has to be bigger than that because shotguns contain it inside of the shell. What they did is they decided the interior of the shell should be standardized to that same bore diameter. So when you fired it, whatever was in the shell would smoothly travel and transition into the barrel. The original idea is that it could have an abrupt change, like you have two diameters like two pieces of pipe. One could be your chamber for the cartridge, and one could be the barrel, almost. I mean, obviously they're not made that way, although you can do that, but that's not really how it's done. So you'd take a piece of pipe that was the right diameter for the bore and just drill a hole in it. Just drill into it from the end to form a chamber. And you can put the shell in it. And the shell length, if you're not aware of it, the chamber length, is based on what it is when it's fired. So you take the unfired shell, make it that depth, that would be your bore diameter. But there were paper hulls. Instead of a plastic shotgun shell casing, they were paper, so they were thicker. So instead of the chamber being one diameter, you have to have two different ones. And that actually is a problem that happened. So someone came up with an idea of making everything tapered and basing it on the maximum diameter for paper shells, which was actually based on them using a completely standardized metal base. It's called the brass, the high brass, or low brass part of it. What they would do is they'd make a washer with a rim on it that was sticking up by forming it. They would take your paper hull, it looks like a thing for coins, stick a cork in it, a short one, and drill a hole in it so they could put a primer in it so it fires some sparks in. And they would jam it into this, and that would trap the paper hull in place. This is an oversimplification. It's not how it's normally done. Then they put it in a press, put in the primer, put some gunpowder in there, put something on it to keep the gunpowder and the pellets, the shot or a slug, separate, and then put something over that to hold it in, and then crimp the top. And they base the length on the chamber diameter. When you put it in, it would fire and pop, and you could reuse that shell a lot. Some of them were waxed so they could handle bad weather too. But they had to accommodate for the fact that paper could swell. And that rim at the bottom, or more accurately, the brass base diameter, is the only part that was ever really standardized. So what is the formula? Well, we'll start with the base and go in. Rim diameter is 0.887 or 22.53 millimeters. Everybody rounds it off. Usually you want to make it bigger if you're making a chamber or a gun, and make it smaller if you're making a cartridge. And that's at 0 depth from the breech end. Right when you rub your thumb over the back end of that shell, that's at 0 depth, and that's the diameter for the rim. At about 1.5 millimeters or 0.06 inches, approximations again, it goes down to a diameter of 0.809. It's actually 0.81 if you want to do it loose and safe, or not, depends on what you're doing. And that works out to 20.55 millimeters. And that's a depth that you would, let's say, drill in for 1.5 millimeters and call it good. Obviously, then there's the space where the shell is, and it's going to be smaller because everything has to taper in such a way that it can't get stuck. Now, it goes from 0.81 inches at the base of the shell, right above the little rim part, and then it necks down to 0.799 inches or 20.27 millimeters. Now again, people are going to round off, round up, round down, but that really works out to 0.8 inches. So it goes from 0.81 to 0.80. Tapers over a distance of approximately 3.5 inches, maybe even 4. Now if you look at that progression, you could figure out that if you just kept doing that tapering for an entire depth of a metal barrel, like let's say you made a tapered or spike-shaped mandrel for your barrel to go on, take your metal pipe blank, get it red hot, mash it down to where it fits over this. You could make it to where no matter what shell you put in, it would have the right depth, diameters, everything. You could even mash in the rim for it if you wanted to, and the whole thing would taper down to the next step, the 0.725 inches or 18.42 millimeter bore diameter. But it's supposed to be the majority of the barrel yeah, but again, shotguns don't really care if they're perfect. They all fly stuff out about the same. You might lose some efficiency, but it'd be easier to make it. Cheaper gun barrels in some cases were just done that way. And then the next step, if you were forge making it, would be to then squeeze that back down to this correct diameter. Or maybe not, depending on how you wanted to do it. Or you might start with a blank that was exactly the right bore diameter and have the chamber in it integrated by squeezing it down. And then you could also do the next step by saying, let's squeeze it down in the last 3 inches and make a choke, reducing it down maybe from 0.725 bore diameter to, let's say, 0.7 for a moderate choke, or maybe a major choke, depending on how you're looking at it. Now, obviously, there's another equation here. I'm talking about making this versus the equation for the chamber and the barrel. But one of the methods that could be thought of, this is interesting, was to taper it from the base diameter of the shell all the way down to the maximum choke used for a turkey gun. And how long would the barrel have to be? You end up with this 36-inch long barrel. I mean, really, these are really long-ass guns. And people noticed that when you looked into them, they didn't have any change in diameter. So it went from a 0.81 bore, breech end, to a muzzle diameter of whatever it is for choke for turkey. And it could be like 60 caliber or something crazy. But if you use the standards that were available, I did the calculation one time, you would end up with a really long goose gun that was really just a very tapered hunk of pipe. And they would use thin pipe because that would work best. What they would do is they would taper it all the way down, but right near where the chamber is, they would add another layer of metal pipe, because if you're not aware of it, one of the metal pipe varieties, water pipe varieties specifically, there's another pipe that'll fit right over it when you do that. Weld that on, reinforce where the shell is for 4 inches. And then carefully grind it down to where it was this neatly tapered barrel, very elegant looking. And when you look down the barrel, it had no interruptions, and it was completely smooth from one end to the other, easily cleaned by you putting in something at one end and just running it through to clean out the interior. So the equation in that case was make it long enough that you can make a choke on the end, and then if they wanted shaking shit, they would just chop off the end of it to make it more open. And also another variety of this was more expensive, was to make it to where you could screw in the same sort of choke changes. So the equation's written below. Thank you for watching. Have a good day. Good luck with that, and I hope this has been informative or useful or both. There's also some more information below as well.